Hi everyone, welcome back. Today we're attempting minimum window substring, a hard question in the Grind 75 series. So for this question, we're given two strings, S and T, of length M and N respectively. We have to return the minimum window substring of S such that every character in T, including duplicates, is included in this window. If there is no such substring, return the empty string like this. So the test case will be generated such that the answer is unique. So there is only one possible minimum window substring. And a substring is a contiguous sequence of characters within the string. So these characters must be in sequence. So for the first example, we have S equals to Adobe Code Bank and T is equals to ABC, and the output in this case is B, A, and C over here. In this case, this makes sense because B, A, and C contains all characters in T, A, B, and C, 1A, 1B, and 1C here. And this is the shortest combination that we can have for minimum window substring. For the second example, we have S equals to A and T equals to A. In this case, the substring itself is really the whole S, and this contains A in T. And for example 3, over here, we have S equals to A, but T contains 2A. In this case, there is no substring that contains double A's, so we return an empty string. So for the constraints, if we let M be the length of S, N be the length of T, then both M and N will range from 1 to 10 to the power of 5, and S and T consists of uppercase and lowercase English letters. And on top of that, the question is hinting us, by any chance can we find an algorithm that runs in OM plus N time? So off the top of my head, one way we can do this is by using a sliding window, and we will keep track of all characters that are present in this sliding window in a dictionary. So if we by any chance expand this window, we will try to expand this window towards the right pointer of this window expanding towards the right, and we continue to keep adding characters into this sliding window until the number of characters inside this window equals that of what we find in T. And once that happens, we try to get a much smaller window by moving the left pointer of the sliding window towards the right. So we try to compress the window in hopes that it still contains all characters in T, and that is in a bid to get the minimum window substring. So the first step of this algorithm, let's say if we have S equals to this test case over here and T equals to ABC, we can first keep track of all characters that exist in T first. So let's say TDIC, in this case this will be a dictionary of string to integers. The key are the characters themselves, and the integer for the values represent the number of occurrences that each character has. So in this case, just to check, it contains uppercase and lowercase characters. So I'm guessing that the characters capital A and small letter a will be considered as two separate characters, because S and T contains uppercase and lowercase English characters. But it's okay, we will go with that assumption first if by any chance we did not get the answer because that assumption is false. It's okay. But anyway, the idea is if we do a linear scan across T and we populate all characters along with their occurrences into a dictionary, then we can use this dictionary to check if our current sliding window contains all characters in this dictionary. This would be more efficient. We don't have to scan through the entire T. We can just scan through this compressed dictionary that represents the number of occurrences we must have for each character. Then we can also define a sliding window dict. This will similarly contain all the counts of characters in this sliding window. And now our job would be to iterate through for character in S. We set this current, let's also define a sliding window left and a sliding window right. And this current sliding window starts with an initial size of 1. So we will first check if M is at least one character. Okay, yes, M is at least one character. So S is guaranteed to have at least one character in the first position. So what we can do is use this right over here to add a character into the sliding window. So for this character in S, let's see. Should we use a character or should we use an index to keep track of what we are pointing at S? We will be expanding towards the right anyway, so the left compression can be done within this for loop. So let's use this as the right instead. For sliding window right in range S. So for each of these current right that we have over here, let's add this current character. So let's call this new sliding window char. I'm being more verbose here so that it's hopefully more clear to our viewers on what is the strategy that we have. So we will set this to be equals to S at sliding window right, and we will set this sliding window character count to be equals to its existing, actually let's call this right and left. I think this will be better, and let's call this char, call this right, let's call this char sliding window dictionary get char 0. Yeah, just so that it compresses the name of the variable. So this will be its existing count plus 1. So if there is no key for char in this sliding window dictionary, we will default it to 0 and just set this to 1. This whole expression over here will evaluate to 1. And once we add the character into the sliding window dictionary, we will check, let's see. We have to check if the sliding window is currently containing all characters in T dictionary. And if it does, then we will try to move left key here, the left index here to the right for this sliding window. So let's see. Yeah, this is fine. So we will check if let's see, all chars in sliding window. This will be a boolean which will indicate if we have all characters in sliding window. So over here, actually let's define this to be false first. We will just edit this on the fly. So this will be equals to any. No, this is not any. So let's see. How do we get a boolean of all? Let's try to, how do we get a check of whether if the current sliding window dictionary contains all characters in T dictionary? Let's define all chars in window. This will be an internal nested function that utilizes the sliding window dictionary and the T dictionary to determine if the sliding window dictionary contains all characters in T. So for key and count in tdict.items, we check, okay, let's set this to, actually no, it's okay. Okay. Actually, let's call this char. This would be more readable. So we will iterate through all characters along with the counts in the T dictionary, and we check if the current characters in the sliding window is more or at least more or equals to the count over here. So if sliding window dictionary dot get char 0 is less than count, then we will return false, else we will return true. Yep, that's pretty much it. So we are iterating all characters and their counts in the T window, and by any chance if any of the characters that are expected to be there is insufficient in sliding window dictionary, we just return false. Otherwise, if this entire iteration for checking all characters passes, then it means that our current sliding window dictionary contains all characters in T. So this makes sense. Let's use this. So if all chars in window, then we will try to move the left pointer. So left plus equals 1, because we're going to move it to the right. And what we have to do is get the left char. This left char will be removed from the sliding window dictionary. So over here we will do let's see. Okay, let's see. Minimum window has returned the substring. Okay. So left char will be equals to S at this left. And yeah, actually we should get the left char before we move it to the right. And we will do sliding window dictionary dot get left char 0. Actually, it will be existent because this left character should be inserted into the sliding window dictionary by now. And we will do minus equal 1. Okay, and what we will do is after we subtract this, we have to check if the current count for left character is enough for T dictionary after getting it out of the sliding window. So let's do sliding window enough is equals to okay, sliding window enough will be set to be false. Actually, yeah, I already defined it here, did I? Yeah, I already did that. So it will be equals to all characters in sliding window equals to this. So the idea is that if this is already true, then it will remain true. If this is false, then this will be evaluated. So if all characters is in Windows, then we will do this. If sliding window dictionary get char count is less than count is less than tdict get char 0, then we will set all sliding window to be equals to false. Yeah, sounds good. So while all characters in sliding window, we will continue to pop the characters on the left side of the sliding window, and we will proceed to continue to move the left character towards the right, the left index towards the right. So if the sliding window if the sliding window now contains characters, let's see, if the sliding window currently, after popping the character on the left window, contains less characters than what it should have in T dictionary, then we will set all characters in sliding window to false, and this will terminate the while condition over here. So else, we will also define a minimum sliding window. Let's call this minimum left, and just call this minimum sliding window. Let's set this to be equals to this, and actually let's just set this to none. Optional of string equals to none. Sliding window length, let's call this boolean of let's set this to the length of 10 to the power of 5 first, and let's set this to an empty string like this, and we will check if the length is, we will check the current minimum, we'll check the current sliding window's length and see by any chance if it is less than this length, and if it's less than this length, then we will update the minimum sliding window. Sounds good. So we will do minimum sliding window equals to okay, let's just let the current window length to be equals to right minus left plus, sorry, right minus left 1 0 plus 1. Then if current window length is less than minimum sliding window length, then what we will do is set the minimum sliding window to the current window. So this will be from left to right, like this. Sounds good. Okay. And over here, we will just return the minimum sliding window over here. So the idea is that we will do a left and right scan. We will scan the sliding window from left to right on S. And if it contains all characters in T, then we will currently set I think there's one bug that I'm doing here. I'm trying to pop the characters too early. I should be doing the check here too. So let me just do this. Okay. I can remove this because it's already done at the start of the while loop. We do not have to update the sliding window at the start and end of every iteration. So this looks fine. Or should we only move the left pointer? No. No, we should move the left pointer after we find a valid sliding window. If popping the left if popping the left would already make the sliding window invalid, then there is no point trying to expand the sliding window towards the right. It's only going to get longer. So doing this is fine. Okay, looks great. Yeah, this looks fine. So let's try testing this out with a test case. So left in this case will be equals to 0. All characters in sliding window will be false. We will set the minimum sliding window to be this string over here. And we will set the existing length for this sliding window to be 10 to the power of 5. We will do this tracing later. Let's set right to be equals to 0. Character over here will be the first character in here. So char will be equals to A. Sliding window for this character will be equals to 1. So let's update this sliding window dictionary and put A equals to 1 for now. All characters in sliding window is equals to all characters in sliding window, or okay, so this is false at the moment, so we will evaluate this check. So for character in T dictionary, let's start iterating this. So character over here will be equals to A, and the count will be equals to 1. So in this case, this would be 1. This would be 1 less than 1. In this case, this will be false. So we will not evaluate that. We will start going to the second character B. Count will be 1. In this case, sliding window dictionary has 0. So 0 is indeed less than 1. This will be true. And we will return false. So we will go back to here. And this will evaluate to false for the first character. So this will not get executed. We will move on to the next index. So right will now point at 1. Character will point at D. And sliding window dictionary get this will be, we will just put D to be equals to 1. And we will check once again. This will be A. This will be A. 1 is indeed less than 1. And then we go to B, and the count for this sliding window for B as usual would still be 0. So this will evaluate to true and we return false. So this will go back to false, and this would not evaluate as usual. Let's move right to 2. Actually, I will leave this here because it's quite clear that we will not have a proper sliding window until we have B and C. So I will skip the tracing from this point onwards. But you get the idea. So now we are at pointing at the third character at index 2. Now we get O. And as usual, we will update O into this sliding window. So this would still be false, so we will skip line 34. We move to right equals to 3. The next character is B. So we will add B into the sliding window. And this would still be false because we don't have C yet. So we move on to right equals to 4. The fifth character in here, so we get E. We'll put E inside here. And this will still be false. We are still lacking C inside our sliding window. So we'll move on. Right equals to 5. We're pointing at the sixth character. So now we finally get C. And now C, we put A, B, C. And just like this, we got our first minimum sliding window. So this will evaluate to true because we now have A, B, C. And while all characters in sliding window, current window is equals to right minus left. So right minus left plus 1. In this case, this will be 5 minus 0 plus 1. So this will give us 6. So since current window length is indeed less than minimum sliding window, we have 10 to the power of 5 here. We will set the minimum sliding window to be the string slice from left 0 to right 6. So this will be ADOB EC. Okay, looks great. So at this point, we just updated the minimum sliding window, and now we prepare to pop the left character. So now the left character is, let's see, left character is equals to the character at the first position. So left char is equals to A. And now we set sliding window dictionary for left character -1, so this will be 0. And we will increment left by 1, so left would now be pointing at 1. Since the sliding window dictionary for this, oh, thank goodness we traced this. Was supposed to check left character. So in this case, this will be 0 less than 1. So this will indeed evaluate to true, and we will set all characters in sliding window to be false. So all characters in sliding window is now false, and we terminate the loop over here. So now that this skips, let's continue with right equals to 6. Now we are pointing at O over here. So O, we will increment this by 1 again, so we get 2. Sliding window dictionary, yep, this is the evaluation that we just did. We just incremented the count of 0 in the sliding, O in the sliding window by 1. And all characters in sliding window will be evaluated again, but this will be false because we're lacking A. So we will continue. Let's go to right equals to 7. So now we're pointing at D. So D, let's increment D by 1, so we get 2. 2 of these in the sliding window. This will still be false because we're lacking A as usual. Let's go to index 8. We're pointing at E. Similarly, we'll increment E by 1. And this will still evaluate to false because we're still missing A. Let's expand the sliding window further towards the right. We get 9. And now the current character is B. Okay, interesting. We get B. And over here, we will increment this by 1 as usual. And this will still evaluate to false. Same reason, we are missing A. We are now pointing at index 10. So we now get finally an A. And now we increment this by 1. And this will finally evaluate to true because we have A, B, we have enough A, B's, and C's. Okay, the current window length will be equals to 10 minus 1, 10 minus 10 minus 1 plus 1, so we get 10. So since current window length is now 10 less than... Oh, did I update minimum sliding window just now? No, I didn't. I think this was supposed to be 6. Yeah, this was supposed to be 6 earlier. So 10 is indeed not less than 6, so this will be false. So we don't update the minimum sliding window. We will get the left character at index 1, so this would be D. And we will decrement D by 1, so we get 1 over here. Okay, so we will increment left again. So left will be equals to 2. And now we are in the process of trying to shrink the sliding window again. So over here, the left character count for D in this case is 1. And in T is 0. So this will be false. So this whole loop will continue again. So right minus left now be 10 minus 2 plus 1. So now this is 9. 9 is still indeed not less than 6. So this will not evaluate. We will not update the minimum sliding window. Now the left character at left 2 is now O. So we will decrement O in our sliding window again. So we have 1 instead of 2. And we increment left by 1 again. And now in this case, we check left character for O. O over here in the sliding window is 1 and T dictionary is 0. So this will still be false. We will not set all characters in sliding window equals to false. So the while loop continues. This will be 8. 8 is still less than 6. Left character will now be at index 3, so B. And now we check. So now we increment left by 1 again. And now we check for the counts of B in the sliding window. This is 2, and the count in T dictionary is 1. This is still false, so this is still false. We still have enough characters in our sliding window. So we continue. Window length is now 7. Left character will now be the character index 4, so that is E. And we decrement the count of E in our sliding window again. Now we get 1. So the count of E in the sliding window is 1, and the count of E in T is 0. So this is still false. The cycle continues. We still continue to shrink the window. Now 6 is still not less than 6, so we still don't update the minimum sliding window. Now let's look at the character at index. Okay, let's see. Left character is equals to, let's see, okay, 4 to 10. So we are at 4 to 4, 5, 6, 7, 8, 9, 10. Okay, we're here. So now we are E. Okay, so now we decrement. Actually I have already decremented that, did I? Yeah, so it should have been 5. So scope bank. Let's set this to C. Okay. (5 to 10). Current window length 6. 1, 2, 3, 4, 5, 6. Yep, sounds good. I lost track of the tracing for a bit. So left character is now equals to C. We are now decrementing the count of C. So now the sliding window contains no C's. And now we can see that this window is not valid. So now we decrement it by 1. Left will now increment by 1 again. So now we get left equals to 6. So 0, 1, 2, 3, 4, 5, 6. Yep, sounds about right. So the current sliding window is from O to A. So now the sliding window will decrement the count for left character. So we decremented that already. Left is already incremented to 6. And now this character for C will be 0. But T dictionary requires 1 C. So this will evaluate to true, and we will set all characters in sliding window to false. And the while loop finally terminates for this iteration. So now we will continue to expand the sliding window towards the right in hopes of finding another C. So now we have right equals to 11. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we have N. Character is equals to N. We increment the sliding window dictionary to have N. So now that's N equals to 1. All characters in sliding window, this will still be false. We are still missing the C, so this will not execute. Let's move on to right equals to 12. Now we are pointing at C. So now this will evaluate to true because we finally have 1 C in the sliding window. So now this will be true. Let's continue. So the current window length is now 12 minus 6, so that gives us 6 plus 1, 7. So 7 is not less than 6, so we will not update the sliding window first. Left character is now equals to character at index 6, 0, 1, 0, 1, 2, 3, 4, 5, 6. So that is O over here. Let's try to pop O over here in our sliding window, so we don't have this anymore. And we increment left by 1, giving us 7. And now we check if the count of O is less than the count of O in TDIC. So we have no O in TDIC, so this would be false. And we continue the cycle on line 37. So now right is 12 minus 7, so 5 plus 1, 6. 6 is still not less than 6, so we still don't update the minimum sliding window. Left character is now equals to character at index 7. 0, 1, 2, 3, 4, 5, 6, 7. I don't understand, my memory is quite bad. D. Okay, now we're pointing at D. Oh, was it D? Just now we were pointing, oh yes, we just went through O, right? So now we're looking at D. So D, we decrement the count in D, and the count of D in the sliding window is now 0, but since tdict doesn't contain D, so this will be false. So we will continue the cycle on line 36. We will continue to shrink the window. This will be 5. 5 is indeed less than 6. So the minimum sliding window will be updated. This will finally be 5. And this will be from index 7 to index 12. 0, 1, 2, 3, 4, 5, 6, 7. 7 debunk. So we're currently debunk. Wait a minute. This is not debunk, sorry. It's ebunk, isn't it? Because we just popped E. So 0, 1, 2, 3, 4, 5, 6, 7. Did I forget to update? Did I forget to update left? Yes, I think I did. So this is supposed to be 8 over here. So 12 minus 8 plus 1, 5. Yep, correct. Yep. It's because I missed out incrementing left by 8. So pardon me, sorry for the confusion right there. But our current minimum sliding window is ebunk. So now we set the left character to be equals to the character index 8. So it is E over here. And let's try popping E from the sliding window. So now we have this, and we check the count of E in sliding window. Now there's 0. There's no E in T dictionary as well, so this will still be false, and the cycle continues on line 35. We will continue to shrink this. So now this will be 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, sounds about right. So now we have bunk. Okay. Okay, looks good. Now we check this current window length. Now this is 12 minus 9. So that gives us 3. 3 plus 1, 4. Okay, so 4 is indeed less than 6. And we update our minimum sliding window to be bunk, like this. And the minimum sliding window length will be 4. Now we try to set the left character to be B. And sliding window dictionary left char will be minus equals 1. So this will be B, A, and C. Why is it that my B was... Yeah, I guess I didn't decrement it. But now the count of B should be 0. I guess I didn't decrement B just now. So sliding window dictionary left char minus 1. Okay, that's what we just did. Left will be 10. And now we check if the left character, in other words, the count of B in sliding window is now 0. But the T dictionary requires 1. So now this will be false. So we will continue expanding the right index in a bit again. But at this point of time, right has already reached the end of the string, so the cycle terminates. And we return the correct answer, which is B, A, and C. Okay, that's pretty much it for this implementation. I'm sorry if the tracing was quite confusing. I confused myself a little bit a few times, but you get the idea. The essence of this strategy is to have a sliding window, keep track of the counts of characters along with their frequencies that we need in T dictionary, and we compare our current sliding window counts as well to tdict. And as long as we do not have enough characters and counts in the sliding window, we will try to expand our sliding window towards the right in a bid to have enough characters in T dictionary. And once we have enough characters, we will try to prune the sliding window by moving the sliding window towards the right as well. We're trying to shrink the sliding window in the bid to ensure we have enough characters, and we just continue to shrink it and shrink it. And every time we find a shorter sliding window, we will update it here on line 22 and line 23. So this check over here on line 37 to line 38. So that's pretty much the essence of this approach. So now that we have the approach, let's code this out. So let's do T dictionary will be equals to an empty dictionary first. This will keep track of all characters in T. So to do that, we have to do for char in T. Okay, we will do T dictionary char equals to T dictionary get char 0 plus 1. So after this iteration from 50 to 51, the linear scan in T, we will have all characters along with the counts in T dictionary. Now we can start to do the sliding window action for write in, oh yes, of course, we have to define a couple of stuff. So we need a sliding window dictionary to keep track of all characters along with the counts in the sliding window. We need a left index that keeps track of the index of the left side of the sliding window. We will have a helper all chars in sliding window, and this will let us keep track if we have enough characters in sliding window. And we have a minimum sliding window. This will default to an empty string under the case where we do not have any sliding window that fits T. And we will also define a helper minimum sliding window length. We will set this to the maximum possible length of m and n, 10 to the power of 5. And we'll be using this length to update the actual minimum sliding window. We will define a helper all chars in window. This helper internal function will help us check if we have enough characters in window. So we will iterate all items in dictionary and check if the sliding window has the character that is by any chance if we have insufficient characters for each character in T in the sliding window. Actually, that was a terrible explanation, but you get the idea. Okay, so now we can start to move the sliding window from left to right. The right pointer of the sliding window from range length S. So this will move from left to right across S. We will get the current character that the right pointer is pointing at, and we will update our sliding window dictionary to increment this character count by 1. And once we are done, we will check all chars in sliding window will be equals to itself or all chars in window. So it will, if this is true, then it will skip it. Otherwise, it will try to check this again. So this is a mini optimization, but the idea is we will just set all chars in sliding window to the correct true or false state, whether if it has enough characters in the sliding window. So if the sliding window is true, then we will set the current window length to be equals to right minus left plus 1. And if the current window length is less than the minimum sliding window length, then we will update our minimum sliding window with this current window. So as left to right plus 1. So once we updated it, we will set the left character to the leftmost character in the sliding window. We will try to pop this out of the sliding window in a bit to shrink the sliding window. We will move the left pointer to the right because we want to shrink it. And we now check if the sliding window is still valid by checking the count of the character that we just removed and see if by any chance we now do not have enough characters for this character. So if this is true, that we do not have enough characters, then we will set this boolean back to false, and this will terminate the while loop over here. But after this linear iteration, we should get the minimum sliding window over here. So yeah, sounds good. I'm sorry if this was a little hard to follow, but I hope this was a decent explanation of that. So now let's do a quick check again to see if this solution makes sense. We are populating the T dictionary to have all characters along the count in T here. We define the sliding window dictionary to represent all characters along the counts in the sliding window. We set the left pointer of the sliding window to 0 first. We define a helper, all characters in sliding window to be false first. No characters, like the sliding window shouldn't contain all characters in T for now. And the minimum sliding window will be an empty string. Set that to the highest value possible first. And we define a function to quickly check if we have enough characters in the sliding window. So what we do is we iterate all characters in T, and we check by any chance for each of these characters, do we have enough of these characters in the sliding window dictionary. If not, return false, otherwise return true. And then we start the sliding window iteration from left to right. So we move the right pointer towards the right in a bit to get enough characters to have all characters in T. And we increment the count of every character that we have into the sliding window dictionary. We check and evaluate if we have enough all characters, if it is still false. Otherwise, if it is true, we update the window and we shrink the sliding window on the left in a bit to get a smaller window substring. So it looks like this is good. Let's run this code. Okay, this passes. Let's submit this. Okay, looks like we failed the test case. CABWEFGEST. Okay, let's copy this test case here and let's try it out. So now we have CAE. Okay, let's do this. Let's do CAE. Yeah, as you can see, testing, in hindsight, testing the algorithm with just one test case isn't enough. It is possible that there are other test cases that would invalidate the current approach. So anyway, we'll try tracing out with this and see where we made the mistake. So T dictionary in this case would be, let's do a multi-line comment over here to represent all characters in T. So T in this case will be equals to C A E. So looks great. Okay, looks good. I'll just remove the commas for simplicity. Sliding window dictionary will be an empty dictionary for now. Left will be equals to 0. All characters in sliding window will be false for now. Minimum sliding window will be empty for now. Minimum sliding window length will be 10 to the power of 5 for now. And then we'll trace this later. Right will be equals to 0. Character in right now at index 0 will be C. Char will be equals to C. Sliding window dictionary char for this C is 0. So this will be equals to, we incremented this, right? Yes, we increment this. So C1, all characters in sliding window will be false, while all character in sliding window, nope, this will not evaluate because it's still false. So we will continue. Right equals to 1. Now we get A. We put A inside the sliding window. and we continue. So now this will still be false because we are missing an E. So right will be equals to 2. Now we get B. Now let's put B here. This will still be false because we're missing E. So let's go to right equals to 3. So 3 will be W. Let's put W into the sliding window. And let's move on to 4. Now we have E. Oh, we finally get the E that we want. So we get E. And now we have this equals to true. This will now be true because we have CAE in our sliding window. So this will be true. Current window length will be 4 minus 0 plus 1. So this is 5, which makes sense. The window has 5 characters. Window length will now be less than 10 to the power of 5. So this will be set to 5. And minimum sliding window will now be from 0 to 4. So 0, 1, 2, 3, 4. So this will be 0, 1, 2, 3, 4. Okay. I wonder why this. Never mind, it's okay. We will figure it out as we trace this further. So now minimum sliding window, because this left character will now be equals to 0. So this is C. Okay. Sliding window character minus equals to 1. So now we have 0. Let's just X this out. Actually, we're going to see C here. So I'll just leave it there and set it to 0. So sliding window dictionary left char minus equals 1. Yeah, we just did that. Left increment by 1. So now this is 1. And now we check the count of C. So the count of C over here is 0 less than 1. So this will be true. All characters in sliding window will now be set to false and the while loop terminates. So now we will try to expand the sliding window towards the right in a bit to get another C. So now we have 5. 5 will now be pointing at F. So we put F into the sliding window. And this will still be false because we haven't found a C. Let's go to 6. This will be G. We put G here. And this will still be false because we don't have a C. Let's go to 7. And now we finally see a E. Okay, now we get an E. And we still don't have a C, so this is still false. All characters in sliding window is still false. We go to 8. So now this is W. Let's put W into the sliding window. And this will still be false because we don't have a C. And now we finally get a C. Now this is the C. So right equals to 9, characters equals to C. And now this is set to 1. And this is finally true. So now we check the current window length. This is 9 minus 1. So this gives us 9 minus 1 plus 1. So this gives us a window length of 9. 1, 1, 1, 1, 4, 5, 6, 7, 8, 9. Yeah, sounds good. Okay, we don't update this because now this is 9 less than 5. This is larger than our current window that we can find, so this is not updated. Left character will now be the character at index 1. So now this is A. So we will decrement A inside our sliding window. Now we get 0. And now we check 0 less than 1. Now this is true, so this is going to be false. So the while loop terminates, and we will continue to expand to the right in a bit to find another A again. So now we have right equals to 10. Previously it was C over here, so now we are pointing at W. So W, okay. And we add W into this window. Now we have 2 W's. this will now be false because we still haven't found an A. Now we go to right equals to 11. CWA. Yeah, I lost track for a minute. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, we finally reached an A. And we finally have a valid sliding window again. This will now be true. And now we will hit the while loop here to shrink this window. So 11 minus 1 plus 1. So this is now, let's see. Okay, let's see. Did I forget to, yeah, I forgot to increment left just now. But anyway, let's set left to 2. So now we are looking at B. Left char is now B. And we decrement B by 1. So now get 0. And let's remove B first. And now B is 0 less than 0 because we have no B in T dictionary. So this is okay. All characters in slide window is still true. And we continue. So now left is incremented. Now left is equals to 3, 0, 1, 2, 3. So now we're looking at W. Oh, sorry. We are looking at left character is now W. So we decrement W by 1. And we increment left by 1. So now this is 4. We are now trying to move the sliding window towards the right. So now this is count of W is now 1 less than 0. Yes, so this is still false. While loop still continues. Now the current, okay, I guess I missed the current window length calculation just now for the previous iteration, but it's okay. Right, 11 minus 4. So 11 minus 4 gives us 7. 7 is still not less than 5, so we still don't update the minimum sliding window. Now let's look at the character index for 0, 1, 2, 3, 4. Now we're looking at E. We are trying to pop E. So E is now 1. And we increment left by 1 again. Now we get 5. And in this case, the count of E is 1 less than 1? Nope. So we continue. Let's go to here. Yep, we are here. So 11 minus 5, that gives us 6 plus 1, 7. 0, 1, 2, 3, 4, 5. So F. Okay, now we have F. Wait a minute. 11 minus 5. So that gives us 6 plus 1, 7. Okay, yeah, sounds good. So F, we decrement F. And now this is 0 less than 0. So this is still a valid sliding window. Let's carry on. Let's now 6. 0, 1, 2, 3, 4, 5, 6. Now we're pointing at G. This is now 6. 6 is still not less than 5. Let's decrement G from the sliding window. And G in both dictionaries is 0. So this is still false. And the cycle continues on line 43. Trying to move the left pointer further. So now this is 5. We have 5 characters now, makes sense. And the left character now is 0, 1, 2, wait a minute. Did I increment 6? Yes. 0, 1, 2, 3, 4, 5, 6. 6. Yeah, actually I should. Yep. This should be 7 actually. 0, 1, 2, 3, 4, 5, 6, 7. E. Okay, so the left character is now at E. And we decrease E. We decrease E. Okay. And now this is now 0 less than 1. So this is now false. 8 to 11. 8, 9, 10, 11. 8, 9, 10, 11. Okay, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So WCWA. Oh, okay. WCWA. Yep, sounds good. So this is now false. So we will try to expand this. WCWA, we're currently here. And now this current sliding window is no longer valid. So let's try to expand it towards the right. Now this is false. Right will now be equals to 12. WCWA. So now we are pointing at E over here. So character will now be E. We will add E into our sliding window. CAE, right? Okay, looks good. So current window will now be 12 minus 8 plus 1, giving us 5. Okay, so 5 is less than 5, so that's not right. Left character will be equals to, let's see, at left equals to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So W, okay. We decrement W in our sliding window. Okay, and now plus left plus equals to 1. So now we get left equals to 9. And this will now be 1 less than 0. Sorry, no, wait a minute. So let me do 1 less than 0. Yeah, this will still be false. So all characters inside the window is still true. Okay. Okay, so now we continue on line 42. Right minus left, 12 minus 9 plus 1. So now this is 4. 4 is indeed less than 5. So minimum sliding window will be updated to CWAE. But the quite curious thing is that we actually managed to get CWAE as the expected answer when tracing. But we got AEFGC. So what this means is that I probably made a bug that resulted in this behavior. So what if I remove this and just evaluate all characters in Windows? Yeah, this should probably pass this. Yep. Okay, let's try this again. No, this is not it. So my assumption that the bug is on line 41 is incorrect. So I'm tracing this incorrectly somehow. How do we get AEFGC? Oh, I forgot to update. I forgot to update this with the new length. No wonder. Okay. Took me long enough to realize this, but yes, this should work this time. Okay, let's submit this. And there we go. So that was not a good run. I made a mistake, and despite tracing, I didn't notice that I wasn't updating the length correctly on line 46. But I hope this was a good demonstration of what would happen if you do not trace incorrectly. The mistake that I made was that I didn't pay attention to updating the minimum sliding window length when I tackled this question. So I hope this was a good learning lesson. I hope it was useful to you, at least when you watch this. But let's continue with the time and space complexity of this approach. So over here, we have a dictionary, and we are updating all characters and their counts into the dictionary. So this would be, if we take n, so let's refresh the aliases first. So m is the length of s, n is the length of t. Okay, And the time complexity over here would be let's trace this out first. So all characters in T, we are doing a linear scan across T. So this is going to be ON. We have a sliding window. So all of this stuff is going to be O1. All the definitions from line 16 to line 20 will be O1. The check for all characters in Windows will be ON in the worst case as well, right? Because if your T contains unique characters, then you will end up doing this check. You will end up iterating the same number of key value pairs as the length of T. So all characters in Windows is really ON. Okay, for right here, we are having a linear scan from left to right across S, so this OM. In this case, a very, like, my personal mentor pointed a mistake out here, but over here for this character, like checking whether if a character exists inside a dictionary over here, the average time complexity is O1. The worst case time complexity is if the dictionary is full and you have lots of collisions. But for all purposes, let's just assume that the average time complexity is O1. The actual worst case time complexity is if K is the number of keys in your dictionary, then it will be OK, assuming that you encountered collisions, but it's okay. Let's take this to be O1 right now. So sliding window dictionary, okay, this updates will be O1. This will be ON. Okay, and this shrinking of the characters from left to right, I would say the worst case is you would move one iteration from left to right. So it's okay to count the time, the manual iteration here as another separate manual iteration across left to right. So it's O2M. So over here, all this stuff will be O1. So that's good. That's okay. So in the worst case scenario, this will be O2MN. So, but we do have this optimization to only do the check on ON sparingly. So I guess you can further optimize this. Instead of doing the entire check here, yeah, we can do an entire check here. Let's see. Yeah, it's okay. It's okay. So yeah, I'm quite curious. How would you optimize this nested ON over here? But it's okay. I guess we'll leave that to another video. But in short, this current time space complexity is O2MN. And the reason is, okay, we have O2MN plus ON actually. So we use ON over here to populate all characters into the sliding window. We do OM over here to iterate through S from left to right using the sliding window approach. It's O2M because it's O2M here because you are iterating one, like in the worst case, you iterate from left to right for the right pointer and you iterate from left to right for the left pointer as well. So that's two manual linear iterations from left to right. But under each of those iterations, like you would check if all characters is in the window. So this is going to take ON nested here as well. So ON equals to O2MN. But if you remove the constants, it's OMN. So this will be OMN plus ON. If we take the higher base, this will be OMN. So for the space complexity, we populate, let's remove all of the notations for simplicity. And over here for the space, we have, we store all characters in T into this dictionary. So this ON. And for the sliding window dictionary, in the worst case, it will contain every character in S. So over here, the sliding window dictionary will take OM. So that's all. Only those two dictionaries will keep track, right? Oh yes, we also have this window over here. We could have optimized this by keeping track of the left and right pointer instead of just doing the string slicing. But this would save the space here. But for all purposes, for this approach, because we use the window over here, this can be up to O N. No, it will be O M. It's possible that the characters that we need in T spans across the entire S. Then you might end up storing all characters in S. So this will be OM. So in summary, our space complexity is ON plus O 2M. But if we remove the coefficients, it'll be ON plus OM. And if you keep track of the left and right pointer of the minimum sliding window, we will save an additional OM space. So that's pretty decent. And that's pretty much it for this approach. So it was pretty embarrassing to get the tracing wrong the first time. But I hope that this was a humbling and useful video to you for how you would solve minimum window substring. Thank you so much for watching. We will see you in the next video.